Okay, I am currently recording. You can hear me well. We have the GitHub repository. Let me put the link here. Shortly, Atif, I am planning to finish grading by the end of this week. Yeah. So you can use the link to this week's datasets and notebook scaffold. I suggest you, okay, I have made a mistake, I guess. I suggest you not to download the scaffold because apparently I forgot to remove some of the codes. You can, I invite you to code along with me as we are proceeding through the lab. Let me share my screen as well, but you can use the scaffold for your lab task. And your lab task also requires a submission from previous session. So yesterday, Alireza during the lab asked you to complete that session's notebook. So both this session and that session must be included in your lab task. And for your lab tasks, we don't expect everything to be perfect. So yeah, just the submission would be sufficient for grading your lab tasks. Okay, so you are currently familiar with what feature engineering is. Today we're gonna see an example of feature engineering together. Let me put the link on Discord as well. Lecture slides, additional resources. We will be using the datasets. On this repository for today's lab. Okay, so we're gonna see an example together. I also suggest you all download the dataset and take a look at it. The lab task will be due for Wednesday, like tomorrow night. Okay? Okay. I'm also gonna be grading your lab tasks by the end of this week. So both your first assignment and 2 of the lab tasks that haven't been graded will be graded. And by tomorrow, you will also receive assignment 2 description, okay? Assignment 2 is basically repeating what we've been doing since yesterday on feature engineering and data wrangling for a new data set. So no worries for your second assignment because it's gonna be pretty much similar to what we've been doing in the lectures and the labs. Okay, so again, if you have the data sets ready, please take a look at them. We're gonna see them together as well. So we have a data set which doesn't have a really good naming, but if you take a look at it, you can realize that each row represents a user session on a page. So there is this imaginary course with the number 46101, and it has several pages. It has an assignments page. We have different pages for different assignments, and we can see that the timestamp where the user has opened this specific web page, and the duration of the time that they have spent on this page. So for instance, here in this row, this user with this ID has opened a page related to assignment 1 on this timestamp, 24th of June, it's not June, May on 1939, and they have spent 40 seconds on this page, okay? And we can see that we have different users, we have different assignments. added to this data set, we also have a grades data set, which shows each user's grade for each of these assignments and their final score. Okay, so these are the two data sets that we have. Our goal here is eventually to develop a model and see if we can predict a student's grade, final grade, or assignment grade based on the time that they have spent on each of these pages. Okay, so this is the final goal. We are tackling these two data sets with this intention. But before we start moving towards that definite goal, I would like to ask you, you are currently seeing my screen, so you already have some ideas about feature engineering, but I would like to draw your attention to the dataset here and ask your ideas about potential features we can extract from this dataset, given the information that you currently have. So if you were to decide the features you want to extract from this dataset, what would be those features? So I give you a couple, like 1 or 2 minutes to think about it, and you can open your mic or either type in the chat. Okay, Ikam says they probably need to review it at least once. Okay, let me put the question this way. If you have the data, okay, Kariman says, I think I still need to see more examples to get it. Okay, guys, it's actually really cool to let us know if you haven't understood something well, okay? Because what we're trying to do here is to help you out understanding the basics. Otherwise, you can ask any generative AI model to do everything for you, okay? So if you haven't understood it well, I think this is actually quite good time to talk a bit more about feature engineering. So let's go over this once again. I believe that you all can see me. My webcam is on. Okay, yeah. So let's say you know which page was opened by which student for how long, okay? So you have a list of students. You know that they have spent a minute or 2 or 5 minutes or 10 minutes on the assignment description. They have spent some time on assignment submission page. They have submitted their homework or their assignments on a specific time. They have spent some time reading the content that you have prepared for them for their assignments. This is the information that you have, okay? And you want, based on these existing data, you want to create a model that helps you predict each student's grade based on the time that they have been spending on each of these pages, or based on the time that they have the timestamp that they have submitted their assignments. So some students might wait until the last second to submit it. Some students might be proactive and submit it a few days before the deadline. So you have different kinds of students, and you want to create a model. This model is going to help you to better understand the behavior of students overall in the course, okay? So feature engineering is the way of turning this raw data into meaningful variables, okay? The whole idea is this. You see the data set, you work with it a bit, you clean it based on the things that you have learned from EDA parts, okay? But one step further is to extract meaningful insights from that data set so that you can understand what's been recorded, okay? This is the whole idea of feature engineering. I can give you example. I can give you one example of what we can do here as a feature, and that is the amount of time that each student has spent for a specific assignment. Okay, so we already know for each page, but we don't know this time for the whole assignment. Okay, another feature can be the amount of time different students has spent on description pages on all of the assignments, for all of the assignments. Okay, so we have like 5 assignments. In total, we want to see how much is a student, how much has a student spent time on the description pages of each of these assignments. Okay, these can be examples of features. Another example of feature can be how soon or late they have submitted their assignment. Okay, so is it like 15 minutes before the deadline? Is it an hour before the deadline? Is it like 2 hours, 2 days? These are the sorts of feature engineering, the features we want to extract from these data set. Okay, and we are going through a procedure to understand and call and define these features. Okay, so here in this example that we have this data set which is related to sessions metrics, we have the timestamp. Okay, but we don't know how many days it was before the deadline. Okay, we don't know about the total number of visits. We don't know about the time spent per assignment. This is just a raw data set. Okay, so we want to use these log data to explore these features. Okay, so before we proceed, I would like to ask you if you have any other ideas for the features that we might be able to extract from this data set, or if we had another data set with more fields, with more information, what would be something that you are curious to know, okay, about the behavior of users on Canvas for a specific course? Is there like any sort of specific behavior you are curious about, which you want to know more about? Okay, late submissions is also a good idea. So currently we don't know if we have late submissions. So this is also a good idea. This can be an idea. Okay, how many people are submitting before time? Yeah, that's also another idea. To answer this specific question that I've asked, you can also go beyond the current data set. You can imagine that we have a magic data set that has everything logged in. What would you like to know more if you had that data set? Is there any specific kind of correlation that you're interested in? Because we also have the grades. We also know how well the students have performed for each assignment. Michael said maybe which specific pages on Canvas are visited the most often. Okay, and he's also interested to know if they have been most useful. So this is also another interesting question. One idea might be if somebody has spent more time on a page, if they have achieved a higher score, that can be a metric of measuring the usefulness of that page. Mina Hill says usage pattern. Can you be a bit more specific about the pattern you're interested in? Yeah. Early submissions to high grades. Yeah, that's also another interesting question. Okay, that's cool. That's cool. I'm glad to see that we are all like pointing somewhat to common features, common questions. Okay, so oops, let me just select the kernel here. Python environments. I have this here. Okay. So here the features. Mina Hill says, Kane says, I would be interested if students working in certain times would output a better grade compared to midnight late. Yeah, that's also another interesting, like we have night owls and we also have early birds. Okay, that can also be a metric of the behavior of their studying behaviors. Okay, if we have like other data sets, for example, their courses schedule. Okay, if we see that they have been spending times overnight for their assignments while having a dense schedule, that might also raise this question that whether they are attending their classes or not, because we don't usually expect somebody staying late till midnight to attend all the classes regularly. Okay, or they have like a superpower of like lack of sleep tolerance. That might be a superpower. Less courses correlation to higher grades. Yeah, that also can be another question income, but unfortunately this data set, I don't think it's gonna answer this question. So it's okay. It's cool. It's cool. We all have interesting ideas. So we're gonna go and we're gonna proceed and see how we can extract these features. So first of all, let's import all of the necessary libraries we usually use. We want to use NumPy, we want to use, and I would like to ask you to proceed coding with me. Okay, we also need Matplotlib to draw some figures. And we also want Seaborn as SNS. Okay, so we also want to use the default style for our Matplotlib for the plots that we're gonna create. So we have a log data frame. We're gonna ask Pandas to read this for us. Transformed dataset.csv, and we also have grades, which is grades data.csv. Okay, let's see, let's double check if we have read them properly. So let's check the first 10 rows for each of the data frames. Okay. Okay, I need to install this. Okay. Okay, I think it's installed. Can I run it? Okay, so we have successfully imported both of them since we are zoomed in. Okay, this is the full table. I can actually print something in between. Print this. Okay, let's zoom in again. Okay, we have both of them imported successfully. Okay, let's proceed. So we want to accumulate some useful counts for each user, okay, to have some like basic insights of what's gonna happen here. Just give me a second. Okay. Yeah. So we want to have some grouped information of each of the students. So we're gonna use the log, and we're gonna use their user ID and assignment, okay, size that's unstack fill value equals to 0. So what does it do? It actually counts the total page views per student per assignment. So this is one of the questions that we asked. We want to see for each of the students, this group by here, this actually form a group of every student assignment pair. The size function here, the size method here, it counts how many rows are in each group. So for each pair of user ID and assignments, we're gonna count the number of the rows, and we're gonna using this method, we're gonna add all the assignments into one column, and we're filling missing items with a 0. Okay, so let's run this. What am I doing wrong? It says user ID. Okay, this is it. It's like this. Okay, so we're gonna see, we're gonna have a print here to check. Okay. Then we're gonna sort columns to sort them based on each assignment, because we have like 5 assignments and we don't want to have any like arbitrary order. So we're gonna get this grouped, and we're gonna change the index using reindex, and we're gonna use the sorted list of columns. Okay, axis equals to 1. Okay, so we target this axis. We want to have the columns. Okay, so we're gonna change the namings here. These are just for better understanding the output. It's gonna be more readable when we use this. So we're gonna say okay, column top count for column input that's column. And ultimately, we want to have a user ID column instead of data frame index. So we're going to remove the data frame index, data frame index column. Okay. Eventually, we want to see for like each of the students how many the count of the pages that they have visited. So let's have a print function here. Okay, so assignment counts the shape. Okay. Okay, so we have grouped them together, each pair of user ID and assignment. Okay, and we can see that the shape of this table is 56 rows to 6 columns. One of the columns is user ID, and the 5 other columns are related to each of the assignments. Okay, so, and we can see for each of these students, this is like the first 5 rows. So we can see that user 1 has 38 visits for assignment 1, 37 visits for assignment 2, for assignment 3. This is what we have so far. Okay. Similarly, we're gonna do the same thing for time. Okay, so instead of counting rows, we're gonna add the value of each row, so that we have the total view length for each of the students. So we're gonna do almost the same thing, similar to the groups here, with a bit of difference. Okay, so we're gonna define a variable which is time totals, and we're gonna do the same thing this time with the log data frame. Here we're still working with the log data frame, so we're gonna again group them by user ID and assignment. But this time, we specifically want the view length value. So we have chosen each of these pairs. We have a row. In this row, we want the view length, the value of the variable inside view length column. Okay. And now that we have it, we're gonna calculate sum, and then we're gonna unstack them. So to understand it better, unstack, also known as pivot, series with multi-index to produce a data frame. Okay, so this time totals returns another data frame for us. We're gonna do the same thing here to have a better labeling, just as shown here. So time totals equals to time totals dot reindex. We're gonna reindex. We're gonna sort them again based on the columns. Okay, x is equals to 1, and then we're gonna have the labeling. That's columns equals to. If this f notion here is new to you, it technically in Python it allows us to have a variable within a string. Okay, we are currently using this variable within this string that we are defining here, and this f notion enables us to do this. What does reindex do? That's a really good question. Okay, to answer this, I always would like to, I would also always like to invite you to check the documentation. That's the best way of doing it. That's the classic way of doing it, actually. So let's search this together. Reindex pandas. We can have the definition here. We can use the official documentation. So we're going to read this. The Pandas data frame reindex method conforms a data frame or series to a new set of labels along a specified axis. So we're going to have the same data frame, but we're going to use different axes for the data frame. Okay, this is used when we want to reorder or add rows, okay, or columns. That's how we use it. And if you check the official documentation, that also says the same thing. Okay, conform data frame to new index with optional filling logic. Okay, so when we are setting index, we're having new labels for the index, for the specific index. Okay. Anyways, yeah, we were here. Yeah, so we're gonna change the columns labeling. Column total time. If it's, you're welcome, Minail. If it's a bit confusing for you, we can actually change this here and see what happens. So you see, I'm gonna add a space here and run this cell again, and we have this space here. Okay, so what we're doing, we are changing the labeling of the columns using this, and we can also check what happens if we set this to 0. You see, we have not assigned values. Okay, but we when set it to 1, we're saying have the same rows and have the same columns, but change the axis name. Don't change the variable. Okay. All right, so we're gonna say total time spent for column in time totals dot columns. Okay, so this expression here, it returns the list of all columns. Okay, we are saying for each element in this list, I'm gonna put this string instead of what currently exists. Okay, so that's how we change the labels of the data frame. And then we're gonna reset the index so that the change is applied. Okay. Now we haven't done anything for adding the variables together. Okay, why are we resetting the index? That's also a good question. Okay. Usually I invite you to answer these questions, to explore and find the answer to these questions yourself, because for the load of the course, we cannot like teach every tiny bit of details we're doing here. Reset index pandas, but I'm gonna do it here to see them together. Okay. Okay, so it resets the index of a data frame or series back to the default integer. Okay. We don't want to have the non-sequential indices entirely. Okay. These are the common use cases. Okay. We haven't done anything in terms of mergings, so we're gonna merge this together. We have 2 wide data frames with 1 row per student. Okay. By using this merge, what we're gonna do next, which is using the merge method, we're gonna join all of these columns together. Okay, so we have a specific user ID, and we're gonna join other cells in the same row together, so that we have a 1 variable remaining. Okay. To do so, we're gonna have another variable here, which is called assignments, and we're gonna ask Pandas to run the merge function here for us. So we have assignment counts, we also have time totals. We're gonna merge these 2 together. What is the common column between these 2 data frames? That's user ID. So we're telling Pandas to use this user ID column, which is shared between these 2 data frames, And we also specify to merge which one to the other. So the left here means we keep all students from assignment counts, okay? Even if they don't have any rows in time totals, okay? This might be a bit confusing. If you want to know more about what we're doing here, it technically follows the basic concepts of working with table databases and table data sets, okay? So we have two tables. One of them is this one here, okay? The other is kind of the same table, whose columns is the time spent for each of these assignments, okay? We want to merge these two together. A student, like if we consider a specific student, let's say here, it might have some 0 values in its row, okay? So here we are saying, even if you have no rows or 0 values, if the student isn't defined in the time totals, that doesn't matter. We still assume that the student exists because we have its row and the assignment counts table, and we're gonna merge them this way. We're gonna merge time totals into assignment counts, okay? So ultimately we want to see the shape of the final table that we have, okay, which is assignments.shape, and then we're gonna see the columns we have to see how our table looks like. And then we're gonna see first couple of rows on the assignments table, data frame actually. Okay, so the final shape is 54 to 11, 50 rows to 11 columns, okay? So we can clearly see that this is the table, this is the first table we created here, okay, the data frame, and this other part here is what we created here, okay? I can actually do something. Before doing the merge, I can show you how the time totals table looks like, okay? That shape, okay? So you see, time totals is a 54 to 6 data frame. So we have 54 rows and we have 6 columns. And the previous one, the grouped data frame, was 54 to 6. Each of these have 6 columns. One of them is common between them. So the final data frame has 11 columns, and these are the columns that we have, okay? And this is the ultimate data frame that we have here. For each of the students, we know how many times a student has visited the pages related to that assignment, and we also know the total time spent on all of the pages related to that assignment. Any questions so far? Okay, I assume that there's no problem, or you have so many questions that you have given up asking them. It's one of these two cases. Okay, let's proceed with the rest of the session. So we want to know more about what we have calculated here. We want to know more about the distribution. We want to know more about the total time spent per assignment. So You already know and you have already seen that you can create visualizations using Seaborn. So we're gonna have a boxplot for total time to have a sense of what's happening there. Okay, we want to have median, we want to have outliers, and we're gonna use Seaborn and Matplot to create the visualizations, just to have a sense of what's happening here. Okay, so I'm gonna ask Matplotlib to create a figure for us. I want the fixed size window to be 12 to 5. You can set whatever number you're comfortable with. It depends on how you want to show the plot. I'm gonna ask the Seaborn to create the boxplot for us. I'm gonna say I'm gonna use the data in the assignment data frame, but I just want to filter those columns that have total time. Yeah, total time in them. Okay. And we also have we do have a space here. Okay. So yeah, we're gonna say if the title has this string in it, I want it, and I want it to be horizontal, and I want to also customize the color palette I'm using. So let's use pastel colors. I'm gonna set a title, distribution of total time spent on each page on each assignment by each user. Okay, and we're gonna set the font size to, I don't know, 15. I want it to be large. Let's set X and Y labels. Total time in seconds. Y label is assignment number. Tight layout. Plot.show. What's happening here? The age is not defined. Okay. This gives us a bit of overview of what's happening. Is there anybody who would like to tell us what this boxplot says and shows to us? Just what you understand from it. We have some outliers for A2, A3, and A4. Yes, but not A4. We have outliers for A5, which means there are like a couple of students who has spent a lot of time for the assignments. Yeah. Any other thing, guys? Can you tell us how much time in average people have spent on the assignments, on each of the assignments? It seems like on average the mean time is the same. Yeah, for each of the assignments, the mean variable, the Yeah, the mean variable is kind of the same, which is around 15,000 seconds. And I'm curious to know how calculator 15,000 seconds divided by, apparently they have spent 4 hours. On average, people don't spend more than 20,000 seconds per assignment. Yeah, that can also be said, except for the assignment 5, which apparently has been a like really complicated assignment. Okay. Another question one might ask here is whether there is a correlation between the number of visits and the total time spent. Okay, so we might be measuring I wish I only needed 4 hours to do an assignment. Yeah, I mean, the lab, I wish, I hope, and we plan the lab tasks not to take more than an hour or two. So I at least hope that it's not taking you more than that to do the lab tasks. Okay, what we're gonna do next is we're gonna see if we are measuring the same thing by calculating the total number and the total time, the total count and the total time. Okay, so we're gonna create a plot showing us these two next to each other. Okay. We're gonna filter assignments for the total count columns, okay? And we want the columns, and we wanna have a list of these count calls, okay? And n is gonna be the length of count calls. Okay, so it's gonna be plot. We're gonna have some subplots, smaller plots that are gonna be 2 or 3, and figure size 2 rows, 3 columns, I guess. Fixed size equals to 15 to 9. Oops. Okay. Axis equals. We don't want our figure to be messed up, so we're gonna flatten the axis. So for each pair of I and column in count calls, time for that column equals to call dot replace total I think somewhere in the way I have, okay, if we get an error, I'm gonna fix this later. Total count and total time. Axis I. We're gonna have a scatter plot. Okay, we're gonna have a scatter plot to see the distribution and whether there is a correlation between these two. So we're gonna have the columns and time columns. The rest of these attributes are related to how we show the scatter plot. So we're gonna have a bit of transparency here. We're gonna have edge colors, and we are gonna set the line widths to like these parts aren't that important. We just mainly need this. Okay. Set the title to column this time column. So we're comparing these two. Font size equals to 9. Axis I. That's set X label. Count. Okay. Okay. Let's see what it shows us. We can like tweak it a bit, but let's see what we can get so far. Okay, I need to call the plot here. For chain range. Okay, what we're doing here, we're creating some plots, okay? If for a specific plot, if we have fewer than 6 assignments, we're gonna hide it. We don't want to actually show it, okay? Plot that's subtitle total visit versus total time. Font size equals to 13. Okay. Okay, now it's done. So apparently we can see that there is a correlation. Okay. Yeah, that was the problem with the yeah, thank you guys. Yeah, that was the problem with the naming. Yeah. Because I have like the zoom on another monitor and my codes here, I didn't see your messages, but yeah. So we can clearly see that there is a correlation between the time visits and the number of visits, okay? So apparently we have successfully have our first engineered feature, okay? So we already have the feature of the total time and the number of visits, and then we can see there is a correlation between them. Now we want to answer the question whether these features can predict a grade or not. And to do so, we have to check the correlation between these two, okay? To do so, we're gonna calculate Pearson correlations. Okay, you see, the first problem was that here I had missed the like, okay? The like phrase here, because we want to filter columns whose column label contains this string, okay? The other problem that I had was that I changed the column label here. Okay, I changed the column label here, and then I came here, and this was working. Okay, it had a problem with the namings. Okay, so if you have also faced the same thing, yeah, I changed the label above, I changed the label here, I changed the label here, here, okay, and this line. If you have the same error, you have to check your labelings. Okay, the logic here is that when we use this variable here, we are filtering columns that contain this string. Okay, there was a problem with this here. Okay, I think we're cool right now. Okay, because we're doing something wrong here. I think we're doing something wrong here. I have a problem with the namings, because like the correlation matrix, correlation figures, they weren't supposed to be this perfectly correlated. So let's see what we're doing wrong. Give me a second, I'm gonna find it out. It has to be actually something like this. Let me just show you guys from the where I was getting prepared for the lab before. It's supposed to be something like this. Okay, so there isn't exactly a fine correlation between them, so there's somewhat a correlation between them, and okay, yeah, that's done. Yeah, thank you. Yeah, that was where it was coming from. Thanks. Okay, so now we fixed the problem thanks to Minahil. Yeah, this is the scatter plot. As I was, okay, let's clear this out. We have done the merge. Okay, and now here. Okay, let's see what's happening here. Where was total time changed? Okay, Michael, you see here, here in the beginning when I was naming the column here, okay, I had set this to total time spent, okay, and apparently that's where the problem was coming from. So here when I was asking filter to for the total time and to change these together, to replace these two together with each other, that was causing the problem. This key didn't match this column title here. Yeah, that's where it was coming from. Okay, let's create the matrix, and then we return back to this part, because I'm not doing something right here. But let's see the matrix together. It's okay, Atif. Atif, I muted you. Yeah, that's okay. Okay, so let's create the matrix using pandas.drop. We're gonna remove the user ID column, okay? And we're gonna ask Pandas to create the correlation for us, okay? So this expression here, drop, excludes the ID column, and this computes all pairwise Pearson correlations. And then we are going to use Seaborn to have a heat map, okay? So let's see. Fix size 11. We're going to ask Seaborn to create a heat map. Oops. A heat map for us. Correlation matrix. We're gonna use this as the source. We're gonna have annotation. The format is to floating point. Format equals to point, and we're gonna have the color mapping set to cool and warm, so it goes from a blue shade to a red shade. Square equals true. Seaborn. Seaborn KWS equals to shrink. We're gonna shrink it a bit, and then the interval is gonna be from -1 to 1. Plot the title, correlation matrix between grades and count time. Plot the tight layout. Plot that show. Okay, let's. Oops. Okay, so we have a really large heat map table here, which all of the correlation numbers are above 0, so we have a positive correlation generally, and we can from a quick look that we can take over the chart here, we can see the correlation between total count on total time for the same assignment is in the 0.6 to 0.85. This means they are related but not redundant. Each of them carries unique information. They are related to each other, but none of them does the other's job. Okay, so if we want to just use count only or time only, we will miss some details in our calculations. Okay, let's say what we're doing wrong. Okay, here where we were calculating correlation results, we don't have a typo here. We have this range here, grade column equals to yeah, that's correct for IAI. If it's in this and in this, let's see. Okay, I'm gonna fix this in post edit. Yeah, I'm gonna fix this in post edit. Apparently, I'm not doing something right, but I'm gonna fix this later. Yeah. Okay. Let's see how much time we have left. It's currently 7 p.m. We started at 5:30, so we have 10 to 15 minutes. Before proceeding, I would like to ask you if you have any questions. Okay, the problem here is that I'm actually using an empty dictionary, and before filling it, yeah, this condition isn't working here. So yeah, I'm gonna return back to this later. Okay. Another feature, I'm gonna go through this really quickly because we are almost out of time. So another thing that you guys were interested to know, and we actually wanted to work on, is to see how many days before the deadline or after the deadline the students have made the submission. So if you tweak with the data set, if you don't know it beforehand, you might not know when the deadlines are. If you tweak with the, if you play with the data set a bit and you see the distribution of the submissions for each of the assignments, you can have you can ultimately realize the deadlines. Based on the, since I have created the data set, I already know the deadlines, okay? So I'm gonna just, for two of them, I'm gonna show them here, and I'm gonna put the rest of the deadlines on the scaffold for you to proceed with your lab task, okay? So for assignment 1, the deadline was on 27th of May, okay? So I'm just gonna put this here. Okay, so A1 deadline, assignment 1. Same thing for assignment 2, which was okay on June 15th. So we're gonna store them in a dictionary. So we're gonna have deadlines equals to A1 deadline and A2. Okay, so we're using a dictionary here because every time we want to just use the name of the assignment and have its deadline returned, okay? So just let's check we're not making the same mistake we did with the correlation dictionary. So yeah, this dictionary here is filled, and we can simply say see how we can access the dates here. If we want to have a loop or something, that items. Okay, so you see, since this is a Pandas object, we can call attributes on it. So we can have the date, or we can have the time, or we can call attributes on it. So we want to calculate the days before deadline. Okay, so instead of having the deadline date, instead of having the dates where the user have worked with the pages or has viewed a page, we want to see how many days it was before or after the deadline. Okay, so we have the log data frame. Okay, we have a start time, the start time here. This column stores the timestamp when the user has accessed that a specific page. Okay, so we're gonna turn this into date time, into a standard time zone. Okay, this is what you want to do when you're working with timestamps. If you're working with a specific time zone, here we want to set them to UTC. You can use any other time zones if you prefer. Okay, And then we only want to have, for now, we only want to work with the date, okay? So we're going to add another column, which is start time, but only the date. We don't need the hours. We only need to know which day it happened, okay? And we want to store the pairs of student assignment. So we're gonna define an empty list to have them stored. So we're gonna have a for loop, okay? We're gonna have a for loop where we calculate this formula for each of the students for this data frame, okay? So we're gonna have a for loop for the pair of user assignment group in log.groupby. We're gonna group each row in the log data frame by the same pair we had already done. So user ID and assignment, okay? Okay, so we're gonna, for each row, we're gonna have group user and assignment, and we're gonna loop over the data frame, okay? We can check for larger data sets, and in a condition where we have missing points and stuff, we can also add a condition here where we check if an assignment is actually in a deadline or not. So if it's not in the deadlines dictionary, okay, if this assignment here is not in this dictionary, we're gonna pass it. But currently we know we actually have to do this here because we only have deadline for 2 of the assignments. So yeah, I'm gonna do this here. Assignment. Yeah, I'm gonna do this here. We're gonna continue. Otherwise, we're gonna set the deadline to deadlines for that specific assignment. Okay, so this variable stores the deadline for this specific assignment we're looping on. And we're gonna set the dates to, we're gonna sort all of the dates, the sorted list of unique calendar days this specific student has visited this assignment, okay? So we're gonna have a set of the group, okay, we had already created this column, okay? And we're gonna calculate the days before as deadline.date deadline.date minus d dot days 14 dates. Okay, so let's wait a second here to understand what this is doing for us. So dates is a sorted list of all of the dates where student has visited an assignment, okay? For each of the dates, for each variable d in this set, we're gonna calculate the day before based on this, okay? So we have the deadline, we subtract the date where the student has visited this date, and then we're gonna store it in a list, okay? Similarly, we want to see the days that fell within the final week, okay? You can change the final week to final 5 days, final 4 days, final 3 days. So it's up to you. But here we have decided to also have the days in last week where the student has viewed this assignment, one page from this assignment. So for the dates, if okay, so this is also the condition. So days in last week says we're gonna loop over the dates, okay, if the days before formula for this day lies somewhere between 0 and 7, we're gonna put it in this list here. Otherwise, we're gonna just ignore it. We're not gonna put it in this list, okay? And then we're gonna append this specific row or specific element to the row we have. So row here, it was used, let me see. Row is used to build a temporal variable for each student assignment pair, okay? So now we're gonna add so each member of rows is a dictionary, okay, where user ID is equal to user. The user comes from here, okay? So we have grouped them, and the user is a row in this group, okay? So the user ID is equal to user. The assignment is equal to assignment, which we're looping here. We also want to see how early the student has submitted the assignments, okay? So here we're gonna turn numerical values into something more meaningful, okay? So if they have, we have Boolean variables here, first day. If they have submitted on the first day, we're gonna say days before if the length of the days before else not, okay? I'm sorry, it's not a Boolean variable. We want to know if they have started earlier, okay? Yeah. If they have started on the second day, days before 1, if then days before 2, else none. First, second gap. Okay, we want to see the gap between first and second visit. So some students might open the page today and then leave it for the next visit for like a couple of days after, okay? So we also want to see if there is a large gap between two visits. So this can also be another feature, okay? A larger gap might mean they read the brief, thought about it, and then came back, okay? And here we actually calculate the length of days before because we want to know how many times they have visited. So if it's like if they haven't visited the page even once, it doesn't make sense if we submit the first visit of the page, okay? And we want to see the number of days where they have visited this page. So it can be just the length of dates, okay? We want to say how many of those days were in the final week, okay? So number of days final week. These are all features that you might be interested in, the questions you might be asking about the submission, okay? So how many days they have visited, how many of these days were in the final week, how many days were in the final, like 5 days, 4 days, 2 days, okay? As we calculated here, we're gonna just use the length of this set, this Python list, I'm sorry. Or we want to see how proactive they have been, okay? If they have planned earlier, so number of days before final week, which is the length of yeah, I'm gonna say D for D in dates if D is actually larger than 7. And this is gonna be a list. And I think Minahil suggested this one. We want to say if they have submitted after the deadline. Okay, so this is how we're gonna do it. We're gonna say, okay, length of D for D in days before. I'm sorry, I have to fix this. Okay, if D is less than 0. Okay, so if we have dates in days before whose value is smaller than 0, it means that they have passed the deadline. So we want to see how many days they have passed after the deadline to submit. Okay, so let's turn this into a data frame activity summary. We're gonna turn this into a data frame. So we're gonna turn rows into a data frame, and we're gonna check the shape. Activity data frame shape, which is that shape. And then we're gonna see the first few rows of this data frame. Okay, now it's time to face our syntax errors. Okay, line 14 here. What's the problem? Set group date. What's the problem here? We have the group here. Built-in function object is not subscribable. Log a date. The square bracket, yeah, that's my first guess. This is it, yeah. Okay. So we have a 108 to 9. So we have 108 rows and we have 9 columns. This is actually interesting why we have 108 columns, because we had 54 students. So as we can see here, we are, okay, it makes sense because for each of the students, we have 2 assignments. Okay, so if we had all 5 assignments, we would have like 270 rows, I guess. Yes, 5. Yeah, I guess 270. So we can see that for assignment 1, like this student specifically, they have submitted assignment 1 day after the deadline. In the final week, 6 days in the final week, they have visited. The gap between the first and second day was 3 days. The first day they viewed it was 7 days before the assignment, and the second day was 4 days. So, but in comparison, for their assignment 2, they have been really proactive. So they first checked the assignment 18 days before the deadline, and then 12 days before the deadline for the second time. Okay, so we can see that it's talking to us. Okay, it's telling us information about the behavior of students for each of the assignments. But like this other students, they have been really proactive in checking the assignment days before the assignment, but strangely they have submitted they have visited the assignment page even after the deadline was passed. Okay, so what we can do next, we don't have time, but what we can do next is to convert this data frame from wide to long, which makes it easier to do the calculations because we have a rather large data set here. Okay, and then we can have the correlation matrix for all features versus grades, not only the features we calculated here. Okay, not only the features here, but also for all the features that we have calculated here. And then ultimately we can have ratios. Okay, let's say we have a student A spent 2 hours on the assignment and 1 hour on the detail, 50% detail ratio, but like the student B has spent 10 hours on the assignment and 1 hour on the detail spec, so there's a 10% ratio. This is also another feature. Okay, so features come in different shapes and different formats. I wish we could cover ratio as well, but apparently I've been too generous when I was deciding about the content of the lab, and we have surpassed the time. Okay, so I wanted to ask you to do this ratio part for your lab task, but I think it's gonna be a lot. Okay, so what we're gonna do is that I think I will only ask you to complete feature 2. Okay, if you also take the time to complete feature 3, we can. It's much appreciated, and we can consider some extra grades for that. But I don't think it makes your lab task way too large, especially considering that you are going to have your second assignment as well. So for your lab task, you only need to complete this second part, which is really similar to the first feature. The only difference is that you will have more features to work with when you are creating the correlation matrix. Okay, it was a rather long lab session. Do we have any questions? Okay, was it understandable for you? The whole thing we did during the lab. Okay, I'm glad. Thanks, Minahil. Okay, it went a little fast. Well, I was trying to complete the whole notebook in a single session, so I wasn't too fast, but okay, I take that comment. Okay. Do we need to plot our own columns for what we did with Ali Reza, or just submit what we follow the line? You should also include the plot for your own columns too. Yeah. I really wanted you to see the procedure of thinking about a feature and then implementing it. Okay, and I hope that we have achieved it, although we didn't complete the whole lab, which is all right. But I hope that by the end of the session, you have a better understanding of what a feature is and how you can calculate it, especially the second part where we also answered some of the questions and some of the insights you were interested in the beginning of the lab. Okay, we're gonna upload your second assignment tomorrow. This video will be on YouTube. I also tried to record the missing the parts we didn't cover. Okay, Canvas is wrong. I'm gonna change it to tomorrow night. Okay, thanks for letting me know, Kane. Okay, I'm also gonna update the description of the lab task. Those of you who have been in the lab, you know what you have to submit, only completing the second feature in the lab notebook. But for the rest of you who haven't been in the lab, I'm going to update the description as well. Any other questions?
Yeah, sorry.
Yeah, sure.
For submitting like what we coded along yesterday, I just submit that in the lab task. I don't know.
You only submitted what?
What we coded along yesterday. I submitted that for lab task 4 on Canvas. Like I can, it's just like a GitHub link, so I can always like upload the new ones, but like I just put it on.
Yeah, you can upload. You can actually make the change, and like I encourage you to make the change. And as long as your commit is before the deadline, that's totally all right. Okay. Yeah, I also want to remind you guys that the lab tasks are just a reason to encourage you to work on the things that we teach you during the labs and lectures, and it forms a portion of your grade, not so much, and we're not going to be too picky about your lab task. So done is better than perfect. If there's no other questions, we can close the lab tonight. Thank you all for attending. Please ask your questions. Feel free to let us know if you need anything throughout the course, okay? Take care, everyone. Bye-bye. Good night.